the calculator trick for this scenario is not going to give the critical value. So you still have to know how to do that the way that we did it before. The calculator trick will give the test statistic and the p-value. That's what it will give. It will give you p-hat also, but it'll give you the test statistic, which is needed for the traditional method, and it will give you the p-value, which is needed for the p-value method, or whatever the heck you're asked for. So you're looking for, actually, let's look at my calculator. Where should I go? Let's see if you guys can figure it out. So here's my calculator. I'm going to go to stat. And I want to run a test. We've been here before for confidence intervals. And remember I said skip this test stuff because we're not doing tests yet? Well, now we're doing tests. But which one are we doing? Well, we're doing a 1 sample proportion z test. 1 prop z test. So when you're doing the calculator trick, that's what you're looking for. 1 prop z test. Oops. Okay. So, well, let's go there. 1 prop z test. So scroll down. 1 prop z test. On mine is 5. I don't know about yours. And then look at what it's asking for. Okay, so some of you have TI-83, so it might not ask for this blue. It doesn't really matter at all whether or not the color is blue or another color. P naught. P naught is the claim basically on the null, okay? So it's asking, what the value is, what the claimed value is. And in this case, the claimed value was 0.5, right? So P naught is 0.5. X basically is the number of successes, which we determined was 856. N was the sample size, which we said was 1228. And then the next step is to determine, or it's basically asking which of these is your alternative hypothesis. Is it a two-tailed test, left-tailed, or right-tailed? So when I scroll here, I'm going to scroll over here and highlight a right-tailed test. This is basically stating the alternative hypothesis, which, if you remember, was P greater than 0.5. So, right, greater than the claimed value. So I don't care what color you use. Let's go down and calculate it. Boom, here's my output. The first thing that's here is the alternative. Prop greater than 0.5. That is your basic, that's your alternative hypothesis. The proportion bigger than 0.5. Make sure that matches. What is the next thing? Z is 13.81. That is my test statistic, which I found using the formula also. Z is 13.81. The next thing, P is equal to 1.12 times 10 to the negative 43, which we said was basically approximately 0. That's my p-value. And then it gives me p-hat also. P-hat, I didn't have to do that. P-hat was 0.6971, so I got the same thing, 0.6971, and then just check your sample size. So it gives you, in this order, the alternative hypothesis, check that, the test statistic, the p-value, p-hat if you want it, and then you should already have the sample size. So it gives you all that, and then you can run whatever test you want. Most of the time, if you're doing it this way, you have the p-value in your face, you can really go straight into p-values less than alpha, I'm going to reject. So the p-value method is favored now because it could be a little bit faster than the other method because we still have to find the critical value this way, how we did it here in inverse norm. So again, the calculator trick gives me the test statistic in this order every time. In test statistic and the p-value. P-hat if I want it, and then N if I want it, okay? So I don't technically have to use the formula, and I don't technically have to do normal CDF for the p-value. The only thing that it doesn't give me is this critical value. So I still have to do that part. But all right, less work though. If I need the test statistic or the p-value. So, obviously, I wanted to, you know what, let's verify. Oh, we already did. We verified these values here. So obviously I want to do another one. All right, so let's do this one. Lie detectors. Trials in an experiment with a polygraph yield 98 results that include 24 cases of wrong results and 74 cases of correct results. Now, I'm not sure what I want here, so I'm not going to say which one is success and which one is failure, because I kind of want to know what I want to determine for the population. So, but I do know the sample size is 98, right? I have 98 total results. Use a 0.05 significance level, my alpha, 0.5 or 0.05 significance level, to test the claim. Here, test the claim. Now I'm going to write my null and my alternative hypothesis. Test the claim that such polygraph results are correct less than 80% of the time. I am making a claim about a population percentage, which is a population proportion. So that is about a p, small p. You're going to have to determine which one, right? Because you guys are going to have a combination of word problems. So in this case, p, because it's about a percentage. Less than 80%. My alternative would be less than 80%, less than 0.8. My null would be equal to 0.8. Always percentage in decimal form. This means that I have a left-tailed test, and I need to determine the number of successes, but because I want to basically run a test about correct results, then I'm going to look at correct results here as well, and that is going to be my number of successes. Yes, always equal to for my null hypothesis. So again, let's read it. Trials in an experiment with a polygraph yield 98 total results that include 24 cases of wrong results and 74 cases of correct results. I do not know which one of those is going to be my success until I know what kind of test, what kind of claim I'm making about the population. Use a 0.05 significance level to test the claim that such polygraph results are correct less than 80% of the time. So I'm talking about correct now for the population proportion. So I'm going to talk about correct results for the sample proportion. I'm not going to find this, but p hat is x over n because my calculator will give that to me. And let's go and find all these values. I want the test statistic, I want the p-value. And from now on, I'm going to use the calculator trick to find these. The calculator trick is going to give me the test statistic and the p-value. But to find the critical value, I still have to do, that other stuff, which for now I'm going to draw the curve. Eventually, I probably won't. Every time we make a claim about a population proportion, we're always on an SND curve. Always on an SND curve, which means the test statistic is always a z-score, and the critical value is always a z-score. Every time. Let's find the critical value first. This is something that everybody always forgets because they're so used to the calculator trick. So I'm going to always do it to make sure you know how to do it. And you should know how to do it because we've done it over and over again, Chapter 6, Chapter 7, and now Chapter 8. This is a left-tailed test, so I want to determine the location of my rejection region, which is in the left tail. Alpha represents the area of that region, and alpha in this case is 0.05. The critical value is the value that separates that from the rest, which I'm going to find by doing what? Do you remember? I want a critical value, meaning I want a z-score. I know an area, so I'm going to find or use inverse norm. I'm on an SND curve, so the mean is 0, the standard deviation is 1. The area to the left, it's a left-tail test, so the area to the left is automatically just 0.05. Let's find the critical value, which is, in this case, negative 1.64. Sometimes with these you take negative 1.645, but if I'm close with my test statistic and my critical value, then I might take more than just those, but 1.64. So negative 1.64 is my critical value. Okay, now let's find my test statistic and my p-value, right? This part is technically new. But not very difficult because I'm just plugging it into my calculator. So I'm running a test. I want to test statistic. I want a p-value. So I go to stat and I go to test. Which one is it? Well, it's a test about a proportion. So I'm down here to prop. And it's got one sample, so I'm one prop v test. I mean, it basically tells you which one to do. P naught is the value on the null. So in this case, it was 0.8, 80%, so 0.8. X was the number of correct results, which is 74. And then N was the total number of tests or whatever, 98. We said that it was a right-tailed test. So over here, I want to make sure, a left-tailed test. So I want to go here, how do I know it's a left-tailed test? I look at the alternative, and it points to the left. So I want to make sure that that one is highlighted. Down to calculate. And then the first thing that pops up is the alternative hypothesis. The next, in the same order, is the test statistic, then the p-value. If I want p-hat, it gives me that too. So let me write down this stuff. So my p-hat, I'll start there. If I were to do x over n, is approximately what? 0.7551. So 0.7551. The test statistic is negative 1.11 in the left tail, negative 1.11, and the p-value is 0.1332. That's a pretty big p-value. 0.1332. Can the p-value ever be negative? P-value is an area, so it should never be negative and it should never be bigger than 1. Okay, so I gathered all my information. Let's go back and now run the test. Now, I'm going to do every single test. So I'm finding every single piece. I'm running every single test. So it's going to take me a little bit more, but I already know what the conclusion is because I can see it and tell. Obviously, I've done it a lot, right? So, and I'm showing all my steps too. Using the traditional method. The traditional method says, if the test statistic is within the rejection region, then I reject the null. But if it's not, then I can't reject the null. I fail to reject the null. So where is my test statistic? My test statistic is negative 1.11. My critical value, which separates the rejection region from the rest, is negative 1.64. So my test statistic doesn't exactly make it into the rejection region because negative 1.11 is closer to the center than negative 1.64. So test statistic is not in the rejection region here. So I'm going to, based on that test, fail to reject the null. Fail to reject the null is my conclusion here. Again, using the traditional method, the test statistic is not in the rejection region because this value, which is negative 1.11, is not exactly to the left, right? It doesn't make it there to past negative 1.64, which is this value here separating this stuff from the rest. So I'm failing to reject based on the traditional method. Using the p-value method, I'm comparing the p-value to alpha, and the p-value is definitely bigger than alpha, right? 0.13 is bigger than 0.05. And if the p-value is bigger than alpha, then I fail to reject the null. I come to the same conclusion, either method. Fail to reject the null. Now, interpretation of that is kind of what I'm going to type this time just so it's cleaner. But interpretation of what you're stating there, I'm failing to reject the null, or I'm not, I'm rejecting the null. What does that mean for your situation? In this case, if I am failing to reject the null, what is failing to reject? Not rejecting. I am not able to reject this, right? So therefore, I cannot support this. So we say there is, I'm not supporting the alternative. So that means there is insufficient evidence to support the claim that, let's go back here. Such polygraph results are correct less than I. Such polygraph results are correct less than 80% of the time. Right? I'm not supporting this claim, which says that P is less than 80%. And P represented the percentage of polygraph results that are less, or less than 80%. So I'm going to have to put in that, and therefore, I guess it's a good polygraph test, as long as you're getting, I probably want to be a little bit more accurate than 80%, but whatever. Depends on what they're doing with that. So, question.